Hi everybody, I'm Alexander Paschall and welcome to the stream. Today I've got Wes Bunn, our technical writer, with us, and later on we're going to have Nick Whiting joining us in by phone call, or Skype call I should say. Today's topic is blueprint optimization, best practices, tips, tricks, what you should and should not do with blueprints. So let's go ahead and start off with documentation that's already available that's going to kind of get you into the flow of things. We'll show it up on the main screen here.
Is our screen up? Yeah, there it is.
Yeah, there we go.
So we have some new documentation here for best practices. Lauren Ridge on our team here has created a general do's and don'ts when it comes to working with blueprints. It's right off the main Blueprints visual scripting page here. If we scroll down a little bit, there's an option for blueprint best practices. So that's how you can find it. And it covers a wide variety of different things, working with the level blueprint versus blueprint classes and what each of those can give you and how you can use each of those based on your situation and your needs. We're not going to go through this here all together, but I did want to highlight the main topics here: class variables versus local variables and how you can use those. A big one is functions versus macros and when to use each of those. And then it goes into blueprint communication types, general tips. Again, you can kind of scroll through this at your leisure and learn some of the best practices here at your own pace. The other thing that we did want to touch here as far as the documentation is concerned, and we'll go into this a little bit later towards the end of this first segment here, we want to talk about Profiler. So I'm going to pop that page up here. If you search from the main documentation page, search for Profiler, or you can see in the nav bar where it sits in the tree. We'll talk a little bit about Profiler here and how you can use it with blueprints. Profiler itself is pretty exhaustive.
We'd have to do like a whole stream just on all the stuff you can do with profiling, like GPU profiling, CPU profiling. It's quite an interesting piece, actually.
Right. So I think just to kind of get your feet wet, we'll show you how to get to it, just the basic navigation of it, and the general things you can kind of look out for if you're getting hitches in your games, how to identify where all the time in your blueprints is being spent, and kind of help you narrow down some things that are going on in terms of your blueprints. Again, instead of covering rendering and all that stuff, we're just going to focus on some of the blueprint stuff. So we'll get into that a little bit later, but I did want to show you this page again so you can kind of go and look over the details on how to navigate the profiler when we get to it. So with that, let's actually close these.
Yep, I've put the links up in the chat, so you guys should have them.
Okay, so what we're going to do here, Nick Whiting is going to be joining us a little bit later, right?
Yeah, he should be in 15 to 20 or so.
He's going to probably provide more of the why. What we're going to do here is show you some examples, just some best practices or some tips from our perspective, covering some of the general use cases, the things that you use the most. So we're going to jump actually into the editor here. I have a sample project up with some examples here. So I'm going to hop in actually. First thing we're going to talk about is tick. So I'm playing in the editor here now, and this is not fancy. Along the left here you can see the text for 100. Right now it is ticking my mock health. I didn't want to create a UMG widget and all of that. I just, for debug purposes, this is perfectly fine. This is my health, and this is ticking every frame. So tick, you got to be very careful when and where you use that. In a single player scenario, using tick to run a couple things here and there may be perfectly fine. However, you do got to be careful if you're calling a lot of things on tick. That can start to bog your game down. And especially in a multiplayer scenario, you and I were talking about this earlier, depending upon tick is not very reliable.
So to give a complete explanation, so tick is frame-based execution. So when you're executing on tick, it's literally saying every frame do this thing. So if I'm running at 60 FPS, but my friend has a really bad graphics card and some other bad stuff, and he's running at more like 25, 30, guess who might be taking damage faster, you know? So multiplayer, not so much.
Yeah, you just definitely got to be aware of where you're using it. And again, in the profiler, there's actually an option to see everything that is ticking, both actors and components. So again, that's very useful to kind of identify where all your resources are being spent. So back to our example here. One of the things that I wanted to kind of touch on here, and I went to lunch with Zach Parrish the other day, and I told him we were doing this stream, and I asked him, I said, what are some tips and tricks that you would use, for optimizing your blueprints? And the first thing that he mentioned was using child blueprints as often as you can. And so I kind of want to demonstrate that really quickly here. Let me go ahead and, so we have our character here on screen running around. And let me hit escape, actually. And say we wanted another character. So I created a little box character here. Again, it's not fancy, it's just a box that can move around. What we could do, if I open the third-person character blueprint here, this is all the script for our third-person character. We could duplicate this script in another character to provide that functionality, or we could make another blueprint, a child blueprint of this, which will inherit any functionality that we put in here, or anything that we add to this blueprint will be passed down to the child blueprints as well. So it gets you a little bit extra mileage, and it doesn't require you to add additional script. So we have our child blueprint here, which is just this box, and he has some other script in here that we'll talk about in a minute. But you can see he doesn't have all that other script that our third-person character does, because he's inheriting that script from it. So not only does he get all that movement that the third-person character gets, but we can provide any kind of unique functionality that we want for the specific character in here. So if we hop into the editor here and play, so I have my character here that can run around and he can jump. And if I switch to the other character, this character can do the same thing, walk around, jump, but I can also do some additional functionality. If I press R, it scales up and gets bigger. I press R and it goes back down. So just an example of using child blueprints here. We've inherited all the movement from our third-person character, but added some additional functionality as well. Now this is not just for characters. If you have pickups or any other kind of blueprints that share some functionality that you want to pass to other blueprints that other blueprints can use as well, that will help in terms of optimization. There's actually an example of this in the content examples. If I click on this link here and pop that up on screen, pull this in.
Yeah. So if you're familiar with the content examples project, we have a lot of stuff to work with in there. And there's a child blueprint section. This is under advanced blueprints, correct?
It's class blueprints. It's
blueprints advanced. Yep.
Blueprint advanced.
So you'll get the content examples project, load up the blueprint advanced map, and you'll see down the hallway there's all these really great pickups. I'll give you a good idea of how that works.
Yeah, so this example is basically showing you a pickup, and they all do different things when you pick them up. But they're sharing the same functionality of rotating and bobbing up and down, being able to determine when the actual item was picked up, etc. So just a good example of using child blueprints.
Yeah. Now, to go back just a little bit, people are asking, what's a good use of tick? Since I know that we tend to be like, ooh, tick, very scary, it's actually very good for a lot of rendering stuff. And I think did Nick just connect in? I think so.
I did.
Oh, hey. Hi, Nick.
Hello.
Hey, how's it going?
Hey, Nick, how you doing?
Not too bad.
Good. Glad
Hey,
you could join us. Thank you so much.
Perfect timing. I was just about to start talking about when you want to use tick, the best times, and you know what? You'll probably be way smarter than me on that. So
Me as well.
So yeah, the thing about tick is, it's not inherently evil. Like it does have its uses. It just is one of those things that you should use sparingly. So tick gets fired every frame. So if you start doing a lot of work in there, it'll start building up the amount of time you're spending processing your blueprints every frame. So one example we had was in the Infiltrator demo, the one with like the Rastafarian Cyber Ninja guy. We had a bunch of lights that were kind of all going down the hallway, and they're all kind of blinking in unison. That was done in tick, and one light wasn't too bad, right? It's cheap, it goes in the scene, doesn't really hurt the frame rate. But then we started duplicating it 200 or 300 times down the hallway, and all of a sudden it's costing a huge portion of your frame. It was like 4 or 5 milliseconds of your frame, which is just totally blown out of the water. So it's one of those things you want to be able to use it. It's really useful, for example, for characters and stuff. If you want to have something that changes, every tick, or if you're listening for some event, every tick, or doing some sort of rendering thing, every tick's changing the color of a light or something like that. You just want to make sure that you don't use it on everything, so that everything is ticking in the world.
Right.
Mm-hmm.
And there's also actually a stats group. I think it's I forgot which one it is off the top of my head, but there's stats actors, I think, or something like that, or stat object, which tells you how many things are ticking in your scene. And that's a good way to kind of tell immediately if you're spending a lot of time in tick. If you forgot that you had this one blueprint that had tick enabled, and you duplicated it 100 times in your map, and all of a sudden the time's going down the toilet, that'll tell you how many actors are ticking.
And can you actually see that inside the game with a console command to bring that up?
Yeah,
I think it's stat object or
Stat
stat
object.
actor.
Yeah, I just wanted to make sure in
I'm
case
not sure which
it's
one it is off the top of my head.
Hmm.
But like I said, you can basically we try to reserve tick for hero pieces, basically, like your characters or, a boss or a weapon maybe, and just try to limit its use when it's out in the environment, just because it is kind of an expensive heavyweight operation. If you don't have to use it, don't use it.
Right.
And the other cool thing you can do is, if you only need to use it some of the time, there's actually a set tick enable function which can enable and disable tick. So if you need, something to tick when, it takes damage and it needs to do some fancy effect for a second or two, you can enable ticking for that second or two and then just turn it back off when you're done with it. And that helps, keep your number of ticking actors down.
Awesome.
Awesome. That actually answers a question that we had come in, which was if I turn on tick, how do I get it back off? So nice little checkbox.
Tick enable. Yep.
Very cool.
All right.
I guess, yeah, the next thing that we were going to talk about. Did you have anything to add about child blueprints? We kind of talked about those in terms of, when would be a good time to use them and what they give you by using those. You weren't here for the demo that we just gave of it, but I was wondering if you had any other additional information to provide.
Yeah, so child blueprints are super useful when you have kind of a base that you want to build upon. And in the game teams, actually, here, like in Fortnite, we have usually a gameplay programmer or kind of a more technical designer will make kind of a base blueprint for, say, you have a car in the world. You want to have a bunch of different types of car, like a cop car, a fire truck, a normal car, stuff like that. But you want to have them all share a bunch of functionality, like when they get shot, the horn goes off and stuff like that. We oftentimes have either a gameplay programmer or a technical designer kind of go through and make that base car blueprint that has all that functionality in it, and then the level designers or whoever else can go in and just make a bunch of variations of that as a child blueprint and change the mesh. And maybe they want, instead of just the horn honking on the fire truck, maybe it spritzes water and stuff when it takes damage. To build that kind of one-off functionality from a common shared base functionality is a really good application for it. So we leverage those really heavily. We do it for weapons, we do it for props, we do it for characters, all that sort of stuff.
Awesome.
Yeah. I think the common comparison that we hear here is, you were saying it earlier too, was the animals. Like you have an animal-based class, and that holds like animals have health. They're full of meat. They they run around and they play. But then
meat.
Dogs fetch, cats chase mice, etc.
Yeah, exactly. You kind of go to specific functionality in the child blueprint, but the things that all of them share are in the parent blueprint. And that's really nice because if you have a bug or something in your code, you can fix it once in the parent blueprint, and then that automatically gets propagated to all the children that come from it.
Very cool. Cool. What else do we have? We have, next up, we're going to talk about timers a little bit.
Yep. Let me throw that link up in the chat.
You throw it in the chat? Go for it.
All right. Bam.
So actually the next two topics kind of go hand in hand a little bit, timers and timelines. Cost of timers versus timelines. I'm glad you're here for this because I was not going to be able to explain it, but I am a student here as well. So if you could provide any insight into timers versus timelines, cost estimates for those. I guess, there's a lot of variables that come into effect, but generally speaking, which would you prefer? Which one's better?
So if people don't know the difference between timers and timelines, timers are basically something that fires off at some interval you give it. So you could say, I want some custom event in my blueprint to get fired off every second or every half second. And you can tell it to loop, or you can tell it to go off once. And it can basically it tells you that I want to do something at some point later in time. Timelines are kind of a collection of curves. So, you can blend numbers from 0 to 1 using a nice curve editor. But those things that fire continuously every tick of it. So they kind of have the same problem that tick does, in that it's not free to do that. Every time you tick the game and render a new frame, you're going to be doing something if you use a timeline. So for things, I think you guys had a good example with the taking damage when you step into fire. You could do that with tick or timeline, and just every tick give them a little bit of damage, or check how long it's been since the last time we gave them damage, and if it's been a half second, do it again. But really, a timer would be a little bit better suited to that, because you can say every 0.5 seconds I want to take another 2 points of health damage, and then you can just have a little event that says subtract 2 from my health and go on, and that only gets fired when you need it. So it's a lot cheaper to use a timer than it is a timeline component. Right. But there's some things you can only do in a timeline. Like if you wanted to blend the color of a light or the intensity of a light and have it look nice and smooth, you'd really want to use a timeline for that, because you want it to update every frame and keep blending so it looks nice and smooth.
Right. I think did you provide both those links in the chat, how to use timers and timeline examples?
Let me see here. Oh, let me grab this other one.
I can bring both of those up.
Throw that one in there too. Okay.
Okay, yeah. So there, Alex just posted those in the chat. There's two good examples. The fire example, taking damage. I believe that is the actual one that I did for the timers, how to use timers. So I think I wrote that page. So I think that is the exact example that I gave. And for the timeline, I believe I did a pickup. I think it's the pickup one.
Yeah, it's the wiki page.
The video.
Video 7, changing things over time.
Okay, yeah. So it's like it's changing the location of a pickup, so it bobs up and down and rotates, and changing the light using a timer to that. So it's kind of like what you were talking about as well. Did have an example here in the editor here, but it is the same example that we just talked about. So there's actually no need to go into that again, I guess.
Sorry to steal the thunder. It's just such a good example.
Yeah, right. Let's see. I guess since we covered timers and timelines,
let's open up the fire blueprint.
Do you want to see it?
Yeah,
the
let's show them
right,
exactly what we're talking about here. So when you look at the nodes, you know what we mean.
So we might as well just show it. So here's my character. He runs in. Here's the fire blueprint here. It's got a little box collision on it, and when I step into it, you can see, well, there's two things that are happening right now.
And this is actually very interesting.
Yeah.
So the child, which has inherited the parent's tick event, which is to print a string of how much health it has, it has inherited that, so you're seeing the 100 of the child's health and also the parent's health going down slowly.
Yeah, there's a way that we can override that, and that kind of gets into the macros versus functions discussion.
Which we'll do in a second.
We'll do in a second, yeah. But did want to illustrate that we are losing health here. As we are in it and as we exit it, then it stops. We could do that on tick, find a way to do it on tick, but as Nick mentioned, timers are probably the optimal way to do it. So let's go ahead and open up that fire blueprint really quickly so we can take a look at it. Now, Nick, I'd like your input on this as well, because there's 1,000,001 different ways to go about doing things.
There's never just one. There's always like 50 ways that a blueprint can achieve what you want.
This is the way that I just did it for this example. I do it a bunch of different ways, just depending on the situation. But for this particular example, on event begin play, I just get the player character, cast to it, and create a reference of it. And then when I overlap that trigger box, I then check and see, is the other actor that I hit that player character? And if it is, then we can set the timer, which calls a function inside the player character blueprint, and that's what decrements our health. Now you could drag off this and cast to the third person character here to check, is it indeed the third person character that overlapped this box? But then you'd be doing that every time that you overlap the box, but we only need, we know since we started the game that we are going to be checking for this. That's why I did it that way. So.
Oh yeah, absolutely. And since for example, since this one was, we have one main character, we know who it is that can take fire damage, we know we'll just do get player character and cast to the third person character. Now, if we were in a much larger scale game, like if we're saying do Fable or something in that strain, we could do something like an interface that is flammable, and then we'll cover interfaces in a bit too. But there's always 100 ways to do these things.
Yeah. So to go back to that function thing really quickly, let me go ahead and open that up. So here's our event tick up here that is just taking the health variable and printing it to screen. Since, as Alex mentioned, our child blueprint is also executing this as well, a nifty little thing that we can do is take this script here and collapse it into a function. So let's go ahead and collapse it into a function and just call it print health. And then inside of our child blueprint, which is this, let's right click and say event print health. Did I type it? Yes, I did. So anything that's connected to this now will get called when that function is called in our third person character blueprint. So in this example, we're printing to the screen, but say for example, instead of health, it's, say you want the character to execute some kind of special ability. You could then in the child blueprint execute a different special ability for this character when that function is called, for example.
Yeah, absolutely. So since right now it's not hooked up to anything, we've basically kind of done like a function override where we said, you know what, you really don't function as anything. Though we could replace it with like lose goo or whatever.
Yeah.
You know.
So now it will only show.
Yep. Now we're not getting both the child and the parent because the child goes to null.
We've overridden that function.
Yep. Yeah,
it might be worth showing how to actually call the parent function in there, since people sometimes have a hard time finding that in the child blueprint. Yeah, if you right-click on the print health, you can add call to parent.
Oh yeah, if you so on that red node there, just right-click the node itself, and then so you see how it says call to parent function in the right-click menu halfway down into it. you guys will kind of see, you'll see that that really just goes, okay, I want it to do what the parent says plus whatever else, or do something, then also do what the parent says to do. So yeah, go ahead and click that. And then you'll see we get this new node. And if we hook those up, yeah.
Can't see it.
I'm kind of going to zoom in a little.
I couldn't see it.
It's way up there. Yeah,
There
so
we go.
now it says when I, have the event happen, also call what the parent normally does in addition to whatever else.
Yeah, if you wanted, for example, you could, play a fire effect or something out there if you only wanted the child to actually catch fire.
Right.
On there. So it lets you kind of extend the behavior. The parent will actually change it.
I don't know
Alex
if he
is
just
over
said
here
that.
laughing.
Oh, sorry, he just said,
You wanted
and
the
it's
child to
something about
catch
like,
fire.
when the child catches fire. I feel like a terrible person.
I don't have children, so I'm not as sensitive to this.
Oh, I do. So I'm the sensitive one, I guess.
Oh.
I am
That's
a
awesome.
terrible human being.
We're
Awesome.
both terrible, Nick.
Very cool. So we can continue, I guess. The next thing that we were going to kind of touch on here was casting.
Yeah, so on to the communication side of things.
Yeah. So let's
I got
actually.
the-
You got that link?
Yeah, if you want to show them it too.
Okay.
Open.
So kind of did it here.
So just to clarify, I posted in the chat the just casting how-to documentation in case you guys are curious.
Yeah, I believe that's how to walks you through. Yeah, that one should walk you through step by step through several examples of casting, actually. And I kind of mentioned it earlier as well that you could, off the other actor here, cast to the third person character. And I guess we should describe what casting is, actually, if some people don't know.
Yeah, it's
it's
definitely like a very old concept in programming.
Yeah, the way that we kind of describe it internally, at least on the doc team, is that it's kind of like a treat as, essentially. You're basically checking for example here, is our player character indeed this third person character blueprint? If it is, then we can access the functions and variables and properties inside it. If it isn't, then it doesn't worry about it. It just omits it. And I think I did have an example of that actually on this pickup blueprint here. So we have a pickup actor in our level, which is this nifty little statue here. And if I open that up, there is our other actor. We are casting to check, is it the box character that actually overlapped this pickup? And if it is, which we'll talk about in a moment, event dispatchers, I'm calling an event dispatcher. If it isn't, then we check if it's the third person character. And then if it is the third person character, then we have a blueprint interface, again, which is another topic that we'll cover here in a second. But it's basically just a treat as kind of statement. Is this thing indeed of a particular type?
Yeah. In this example, it's definitely being more used as a is valid check almost, since we're not, after we cast to it to check to see if it is of that class, we're not really telling it to do something, directly.
But we could. I mean, we could
Yeah.
set properties. We could drag off this and set the health from here. We could call any functions from the box character from here. Again, because we are accessing that particular blueprint and able to access the properties and values inside of it.
Yeah. So the kind of interesting thing with this is if instead of using casting we used interfaces, we could definitely we can instead have it say if anything of this that implements this interface type, which I think we have an example of.
An interface, yeah.
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 Then it'll try to pick it up instead. We can do this a few different ways, but since we're just using the one character, again, you're always going to see us doing the third person.
I think it might be worth pointing out too that casting is you can only cast from a parent class to a child class. So if you have a reference to a character, you can cast it to boxy character or third person character. But if you can't cast a character to something that's completely unrelated, like a static mesh.
That's a very good point to make, actually. 'Cause sometimes we forget about things like that. We just assume it's common knowledge, but again, it's not, and it's a very important thing to mention.
Yeah, and another thing with casting is we didn't show, can you do a pure cast just to show what that looks like? Like change that one cast there, like the second one or something.
This one?
Yeah, since the one is kind of being used as an is valid.
Can you right click into that?
Yeah, there it is. It's right there.
I'm blind.
It's
right there.
You got it. There you go. Okay, so now if you hook up the cast failed straight into the item pickup, bam. We could have it like implement something out of here, but then we lose that great kind of is valid, and you still have the valid check from the branch from the success Boolean output too. So
Right.
That lets you clean up a lot of code, though. If you're absolutely 100% certain that it's going to be one of those third-person characters, sometimes it's nice to have that pure cast in there.
Yeah.
Yep, a million different ways to do things. Yeah, did you have anything else you wanted to touch on casting, Nick, before we jump into interfaces and keep moving forward?
No, I think that about covers it. I think, yeah, just remembering that you can only cast from a parent type to a child type is important, because a lot of times people kind of assume, oh, if I have a character, if I cast him to a static mesh, I can, set his material based on that. It doesn't work like that. It has to go from a parent to a child.
That's very true. Okay. Do you want to throw the next link?
Yeah, let me throw up the interfaces link.
So we'll talk a little bit about Blueprint interfaces, and then we'll touch on event dispatchers, and then we'll talk about profiler, and then jump into the Q&A, because I know you guys have a lot of questions, and I want to get to those as soon as possible. So
and we'll go over very briefly overriding functions. That's another thing.
Did we not? We just did that, didn't
I mean, kind of.
We did that.
we didn't use that new fancy override function drop down that's over there. Where was it?
I did.
You did?
I did on the...
Oh, you did.
I did it in here, and we changed it to this. We did it.
They're on the left, though. See it under functions, and then you have constructor script.
Oh, yeah.
So that's like a new
this
thing.
one. Yeah.
Yeah, that's another way to do an override. Just to point it out, like if you click it, there's like a little drop-down menu of things you can override.
Right.
But, all right. So interfaces, right.
So interfaces. Let's actually take a look at this quick example again. So here's our character. There's our pickup up there. The blueprint statue here, which is our quote-unquote pickup, is actually implementing an interface so that when I overlap this pickup, it sends out a message to both the third-person character and our boxy character there, who both have implemented this interface. And both of them can execute their own script based on when they get that call, which is very useful if you have several different things that need to respond to an event and do different things based on that event. So for this example, the character runs over it, and our box changes to a goldish color, and our character can run a lot faster. So I'm only working with starter content here, ladies and gentlemen, so that's why.
It's a little weird looking. This is how we like to roll.
Yeah.
But if you switch to the box, since the box is also
Correct.
using the interface,
Correct.
he can also switch his color by running into the pickup, correct?
Yes. So if I switch over to that.
So this one isn't using a cast to check to see if it's...
This one
able to do
actually, if it is the box character, it's actually going to turn off that fire because I set up an event dispatcher.
Oh, okay.
So
I see.
that kind of gets into the next thing. So we'll talk about that in a moment, how we did that. I mean, it's on that cast inside of our pickup here. If it is our boxy character, we're doing an event dispatcher instead. So just trying to mesh everything together to showcase a bunch of different examples in one. But our interface here, so we've created a simple interface. There's a bunch of, that's not it. There's a bunch of different ways that you could do this. So our interface here is just a function that's being called. We could provide inputs and outputs and variables that we want to pass as part of that interface. But for this example, am I on the interface?
Yep.
Yeah, okay. It's not showing the grid for some reason, so it kind of threw me off. But for our example, when the interface is called, this function is called, and it's being executed in the blueprints that implement them. If you don't know, I'm assuming most of you do, but if you don't know, you can implement an interface just by going up to the class settings of a blueprint. And if we move this window over just a little bit, there's an option to add interfaces. If you click this add button, and you'll be able to find your blueprint interface here that you can add. And once you've added it, then anything that's in that interface you can implement in your script here. So what we've done, we've added it, and then we've added a call to this item pickup here. And I've added a variable here. And Nick, you may want to jump in here. I'm not sure if this is the correct way to do it, but this is the way that I've been doing it. I've added an array of just targets. So it's like a bunch of different actors. And I've made it publicly editable so that on the pickup, if I go to it in the details panel, I could specify, what targets to affect.
Oh, I see. You got a little drop down.
Yeah, because I've made it publicly editable, and I can add, additional things to affect. But they would also have to implement that interface. Every time I've done an interface, you have to specify the target. Am I correct in assuming that, Nick?
Yeah, so if you kind of go back there, I think there's two cool little things to point out if you go back to where you're actually calling the interface. Yeah, right there. One is that a lot of people don't know this, but if you hook up an array, like the interface targets there, to a target pin, even though the target pin's not an array, what the blueprint compiler does for you basically is say, I'll call item picked up on every one of the elements in that interface target array. So if you had 3 items in that array,
Right.
it'll go through sequentially and just call item picked up on it. So that's a really useful way if you have stuff like that where you want to have one pickup item or whatever it is affect a bunch of different things at the same time. You can do that and not have to use a for each or anything like that.
Yeah, very good to point that out, actually, because again, I kind of just took that and did it without explaining it. But yeah, that is an excellent point as well.
Oh, well, I'd say that's extremely useful.
Yeah.
Yeah, it works on functions. It doesn't have to be on interfaces.
Yeah,
it works on both of those.
Just connects it. That's
so
awesome.
super handy.
Yeah.
The other thing was to your other question about the target. Yeah, you have to interfaces are basically like one way to think about them is they're like a function or event on something that will only call if that item implements that interface. So your interface targets there is an array of actors, right? So you can put any actor in the world there, whether or not they implement the interface. And that item picked up will basically ask each actor in that array, hey, do you implement this interface? If so, I'm going to call the item picked up event on you. And if you don't, I'm just going to skip past it.
Right.
So you can kind of mix and match stuff. One of the kind of classic examples we use is like a flamethrower. Imagine if you're making a flamethrower, right? In your weapon, you just kind of trace out in a box or a cone or whatever in front of you and get everything that you touch with the flame. And then you could just call, set on fire interface or something like that. And then only the things that you've implemented that interface on, like maybe a torch as opposed to a stone or a wall or something, will actually respond to it. So it's a good way of kind of, filtering out items that can respond to certain events or not without having to go through and cast, is this a torch? Is this a wall? Is this a piece of wood? Stuff like that.
Right. Awesome. Yeah, I was going to say, I think one of the misconceptions that I've seen is that with interfaces, it's expected that once a blueprint implements that interface, you're kind of done. So even though they've implemented the interface, you still need to specify it as a target.
Yeah, you have to define what its actual actions are, and then you have to call it.
It's just a misconception that I've seen a couple times. People are like, well, I've implemented the interface. How come it's not
it's not doing the fire particle animation and all that. Well, you have to go into the function and say that I catch fire.
Right.
Yeah, I think that's actually another one. I don't know if it's the same one you're mentioning, but a lot of people assume that if something in the world implements an interface, anytime you call an interface message on any target, it'll call all the targets, and that's not true. You have to direct it to the targets you want it to actually call on.
Right, which is kind of what I've done here. So, this is the box character here. All we've done is, again, went to the class settings. This one, actually, I wanted to point this out because it's inheriting from the parent. We don't have to specify for it to implement the interface. It just comes with it as part of being the child. So we can implement the interface here, the event item picked up, and then execute whatever script we want when the pickup item is picked up.
Yeah, and this is just such a great universal function since, for example, I'm actually using interfaces for all of my resource objects in an RTS thing I've been sort of working on for fun. And so it's, anything that can be picked up as a resource is part of this interface and a child of that. And that's generally how you set these things up, is you want to, from the beginning, structure it as this is the base with all of my core elements that everything will derive from, and then go from there.
Yeah, I would say that actually leads to a good question. I don't know if this actually was one of the questions, but a question for Nick here. Interfaces versus casting versus event dispatchers, cost-wise, I mean, is there a large disparity between those?
That's what it always boils down to.
Yeah, right?
It really does.
Which one do I use in which situation? Because they can all be used.
Yeah.
You see here, it's just which one's most performant, and is, I guess, it
So the cheapest way to do it is if you already have a reference to something, just calling a straight-up function or event on it is always the fastest.
Right.
But if you have to cast every time, that adds a little bit of overhead to it. So kind of what you did there with the third-person character, you're casting in this situation, but in the other blueprint example, you actually cached off that reference to the third person, so you do the cast once and then use that everywhere.
Right.
That'll be the most performant way because you can then just call the function directly.
Right.
And then
go ahead. I'm sorry. Go ahead. Go ahead.
I was going to go on to interfaces. Basically, what an interface does under the hood is it takes whatever the target is, does a little query to see if it implements the interface or not, and if so, it calls the function as normal. So it's basically like a little mini cast step in the middle there. It's pretty efficient. It's probably slightly more efficient than a cast because it just does a little lookup into a much shorter table. So it's probably a little bit faster than a cast, but it does kind of make it so that you don't have that nice kind of scoping that you would if you casted something and know exactly what you can call on it. So it's a little more ambiguous. And event dispatchers are probably the least efficient of all those, because basically that's storing an array of functions to be called.
Right.
So every time you call it, it has to go through that array and call it on everything. So if you had an event dispatcher with 10 people listening to it, you're calling a function 10 times, basically under the hood. So that's probably the least efficient. But yeah, the event dispatcher is something that you want to use that when you really want to just kind of broadcast to a bunch of different things at once. It's totally fine to do it that way. Mm-hmm. You just don't want to do it in lieu of like a normal function call. If you only have one object or two objects that you're calling it on, it's probably a little bit better to use either an interface or a direct function call.
Awesome. That is very good to know.
Yeah, it is.
I actually did not know that, so that is very good.
And with that, we're actually going to cover a little bit on. You want to cover a little bit of event dispatchers?
Yeah, we'll go ahead and show the example. I did want to show one thing here, and he kind of mentioned about the direct blueprint communication being like the cheapest way. I kind of did that as well with our third-person character here and our boxy character. So I've created just a character variable here and made it public, and inside of our level here, exposed it so that I can set what the character is that I switch to, so I'm directly communicating between these two blueprints, and did the same thing on this one as well. So I don't need to cast or do anything like that. I can just use a direct blueprint communication to communicate between these two. That's for the switching of characters. So I'm passing that back and forth to one another. So
neat.
Let's go on to event dispatchers here, and then we'll jump into Profiler really quickly, and then get to the Q&A. How are we doing on time, actually?
We've got plenty of time. We've got 25 minutes left.
Good. Let's really quickly, let's go over the least performant event dispatcher friend that we just learned. So the example that we had was our pickup. So as Alex mentioned, when the character goes over the pickup, it changes the box and increases my character's move speed. But if I switch to the box and the box goes over it, what the box does is sends out an event dispatcher to tell the fire to deactivate itself. So the box goes over it and the fire deactivates.
Oh, my hero.
Yeah, right?
We love you, Box.
Yeah, Boxy, our friend. So it's just calling this event dispatcher here that we've created inside this is the pickup blueprint, right? Yep. And inside of our fire blueprint, what we've did, I've moved it all the way to the side because I didn't want to talk about it yet. All we did is on event begin play, we've bound that event dispatcher so that whenever it is called, it executes custom event here, and whatever script is tied to this will get called whenever that event dispatcher is called. So that's the only example that I had in here, but hopefully we sent out the link as well on how to
link
some other. Would you have some other use cases? I think you kind of already gave us some, but
yeah, sure. The difference between a function and an event dispatcher is kind of like the difference between like an email directly to somebody else and mailing a mailing list, right? So a function, you know exactly who you're talking to. You have some reference like the third person reference in there or some other actor directly, and you're just going to call a function straight on them, right? So it's kind of a one-to-one communication, where event dispatchers really are meant to be more like mailing lists, where a bunch of people can sign up, add their names to the mailing list, and then when something happens, you basically broadcast to everybody and let them determine what they want to do with it. So one example would be on died. We do that one in a lot of the games, like when an enemy dies or something like that. There's potentially a lot of different things that want to happen. Maybe your HUD wants to play an effect like, "Ooh, you killed an enemy." Maybe the level itself, if it's a boss enemy or something like that, needs to know to open a gate when the enemy's died, and maybe you need to get power up the game state. You might need to know about stuff. So basically, when a single event happens that a bunch of different things want to know about, an event dispatcher is a really good way to do that, because it can just say, "Hey, I died. Anybody who cares, do what you want to do with this."
Right. Cool. That's kind of the example we gave here too. Awesome. So with that, let's take a quick look at Profiler. Again, we kind of touched on this at the intro to the video that we don't want to go too far into this, but we'll just show you some quick things in here. And Nick, feel free to jump in at any time too in regards to Profiler, specifically with blueprints and what to look out for. So let's just jump in really quickly. And if we go to Window and Developer Tools, Session Front End. So this is where you can access the profiler. There's a little tab. It says profiler here. We are running in the background here, so let's go ahead and enable a data preview. And there's a lot of stuff that we're looking at here. There's a bunch of different bells and whistles here. Again, we linked the documentation if you want to kind of step through what each of these do. But we just kind of wanted to touch on a couple things to look out for in regards to the profiler here. So as you can see, there's some kind of like spikes in the graph here. And again, Nick, feel free to articulate this better than me if you would like. But
you're doing the job, man.
Because I have not used profiler too much, but I did know of a couple things that we could talk about here, specifically with blueprints and tick specifically. So
yeah, this is a great way to find if you have way too many things ticking.
Right. There's actually an option. I kind of wanted to show that really quickly. Down on the graph here, we've highlighted a section that is has a spike in it. And this is very small text, so I'm not going to be able to see it. Feel free to speak up, Alex.
Oh, let's see here.
So what we're looking for is the game thread. So let's find it. It's right.
It's one
Just
right above
you.
Yeah.
Right there.
Yeah, you got it.
And frame time. And under here, what we're going to try to find here is the ftick function task. That will tell you everything, all the actors and components that are ticking. And reducing the number of actors or components that tick every frame is a great way to speed up your game. So if we look under there, in our example, we probably don't have a lot of things that are ticking. So if we find frame time, it should be under world time, world tick time, down here, and GT tickable time. Is this it? No, it's not under here. I don't see it. Do you see the f tick function task?
I hate it because we were looking at it earlier.
I know, I did the same thing earlier.
We took forever to find it the first time too.
Yeah.
Is it the game thread update time, maybe? I can't remember which one's in.
Yeah, I thought it was under world tick time. There's another way that we can get to it too as well. You can kind of see it if we go over, at least the second thing to kind of find it, if we go over to inclusive here, and we can look
There's
for
frame time.
Yeah, we can look for blueprint time. There's a blueprint time in here. Right there. So this will give you a breakdown of all the blueprints that are running at that particular moment. We can hop back over to the hierarchy view here.
Yep. You have it.
And now you can get a look at what is being executed, all the blueprints that are being executed, where that time is being sent, the number of calls that blueprint made per frame. So if you're have some hitches in your game, this would be one way that you can come in and kind of see what's causing those hitches. Again, this is a very in-depth topic, but it's a starting point, I guess.
We'll probably have to do like a full-on stream about it. I mean, as you can all see on that left side, it's just a huge list of things that you can check and see what is and is not acting the right way performance-wise.
Yeah,
I think it's worth noting out that the spikes that you see up in the green on there are the actual hitches in the game. Basically, the lower that line, the faster your game time. So when that line goes up sharply, you did something that's costing a lot of time.
Right.
So if you had a blueprint event that was doing a lot of work on a single frame, you might see that as a bump.
Yep.
Right. Another way you can actually do that too as well, if you go to, is it maximum? Let me get out of, am I in hierarchy mode? Yeah. So if you select maximum, that will sort it as well too. You're looking for the inclusion time, whatever has something that's more than a couple milliseconds. If you have something like, I think one of the examples that I had seen, fonts was like 4.5 milliseseconds for rendering fonts or something. It's like, why is it rendering every frame?
And another weird thing that we discovered was that there is an idling process. So if you click off of UE4 and do something else and come back and it's like, oh my gosh, everything's spiked. That's actually the idling process, and it's not a danger.
It's CPU stall.
Yeah, there it is, CPU stall.
You don't have to worry about those. If you come in here and you see all this red, and you're like, oh, what is all this red?
Yeah, that's
need to
idling
worry about
process.
those.
It's like looking in your your Windows task manager and going over, and you see, oh my gosh, idle is 99%. That's all.
Yeah, another common offender is the tick widgets as well. So for if you want to look for those. Some slate attributes such as visibility may get called several times per frame, so they should be small and returned in a timely manner. It's just another thing to look out for. Again, I think we should do another stream on this.
Yeah, you can go super deep in this. The other thing, in addition to kind of your average time and the tick times, a lot of times if you get hitches, things to look for are if you're spawning actors and stuff. A lot of times that's a slow process because there's a lot to kind of process in one frame. And also activating a lot of particle effects and stuff in big batches. This will help you find those by looking for the spikes.
Right.
Got a little feedback.
a little
Sorry.
bit. It's all right.
Sorry about that.
I think that's actually going to segue into our Q&A, because I know one of the questions was this, and it's one of the questions I had as well, is like, what are the most heavy nodes in Blueprint? Like, I know get all actors of class, I know tick, I know.
Yeah, as a matter of fact, that was one of our first questions.
Right?
Was,
Yeah, so I think we
was
could
exactly almost that.
jump into the Q&A now if you want to.
Yeah.
Actually, before we do that, I wanted to mention this tool right here is, kind of super intimidating and not really, unless you're a programmer and are familiar with this, it's really kind of hard to grok. But one of the tasks that we have just started this week is starting to work on improved debugger and performance tools in blueprints. So one of the things we want to have is basically you can choose a blueprint to profile, just like you choose a blueprint to debug, and then it'll give you like a heat map, draw areas and nodes, groups of nodes that are taking a lot of time in red and ones that aren't taking as much time in kind of blue and softer colors. Like if you've ever seen like, game level heat maps where most people get killed and stuff, we want to do the same sort of thing with performance tuning so that it'll be much, much easier. You'll be able to go right to the node that is causing you the problems rather than trying to suss through that giant list of stuff.
Awesome.
It's all going to be based on the same data, just a lot easier to visualize it.
Yeah, it's going to actually lead into another question that I think somebody had, is determining how do you isolate which node it is. Right?
Yeah, that's definitely awesome.
If you know the node, then it's going to be good. But how would you isolate?
That's the first question is how would you debug the performance of a specific blueprint a specific blueprint node? Let's say I have function X is expensive, but I don't know what node in said function is the bad one. So this would be kind of a way of seeing that.
Yeah, this would definitely help with that because you'd see which functions are being called. The gamepad profiler also will show that information in there. It'll show you which nodes are costing the most time in there. So that's the easiest way, is if you kind of drill down in that tree view on your slow blueprint, it'll show you which node and which function is getting called the most.
Yeah.
If you don't want to do that, one way to kind of get around that is just kind of skip a node, right? Take it, move it up, and then skip the execution on it and see if the time gets better or worse in there. We kind of do that where we do what's called a binary search, where we kind of take off half the graph, see if that makes a huge difference, and then if it doesn't, take off the other half of the graph, and then you kind of isolate it into two halves, and you keep doing that in smaller and smaller chunks until you nail down
the problem.
what the most expensive thing is. So usually it's not necessarily a node that's super expensive necessarily, but groups of nodes for it. Yeah. I think there's a question later on about what kind of blueprints are the most or least performant, and what makes things slow. Do you want me to go right into that now while we're on?
Yeah, sure. I have the question right here. It's which blueprint functions have the worst overhead? So we'll go ahead and address that one while you're on the topic.
Cool. So the thing that gets you most in blueprints is we operate on what's called a virtual machine. Lots of other things do this, like Java runs on a virtual machine, and there's a lot of stuff in your web browser that runs on a virtual machine. And that virtual machine is basically responsible for taking your blueprint nodes, right, and calling the functions that are native C++ functions that correspond to those nodes. The biggest overhead in our system is not kind of once you get down into the functions in the native C++ code, it's that going up and down between the layers, between the VM and the native functions. So we find that you pay the most cost for that overhead if you're doing really, really small bits of functionality per node. So things like if you have long chains of math, like if you're doing a lot of super complex math every tick, the fact that you have to go down to native code to call the math function and then go back up to VM and then take that result and then go back down to native and go back up, that's kind of the worst case scenario for blueprints. So the easiest way to speed that up is if you have a bunch of like common complicated nodes, just write a C++ function and expose that to blueprints. Then you're only paying for one trip down to native and then back up for that. So we tend to optimize a lot by looking for those kind of clusters of nodes that we use a lot that are paying a lot in that VM overhead, and then trying to optimize those into one node. So basically going from many nodes to one node is the single biggest optimization you can do for blueprint stuff.
Awesome. I think that was actually touched on as well in the Blueprint best practices page that we linked earlier. I think Lauren wrote something up about that as well.
Yeah, a bit of there.
Yeah.
Cool. All right. So I guess kind of in that same strain of, what is going to be more there. So if I have a blueprint that I've derived from the static mesh blueprint class, does that have less overhead than if I made just an actor blueprint with a static mesh component?
So the only place where there's a difference in that is if you're spawning them dynamically in the game, because it's a little bit more expensive to spawn a blueprint right now than it is to spawn a static mesh actor, which is what we call a native class because it's made in C++. when you spawn a blueprint, it actually copies the template for the component in there. So your static mesh component, basically, it copies that and creates a new one. Whereas the native code path skips one of the copies. So it's slightly faster, but you probably wouldn't notice it unless you had just an absurd amount of them in there. So if you were like loading a level and spawning 1,000 of those blueprints all in the same frame, it would be faster to use a static mesh actor. But if you're just spawning one, like every time you shoot a gun or something like that, you're really not going to notice a difference. It's a fraction of a millisecond.
All right, really cool.
And I should point out, in the other cases where when you just place one in a level and not spawning it dynamically, you basically pay that cost when you place it in the editor. So at runtime, it really makes no difference. It's only when you have to run the construction script, basically.
All right. In that case, so I guess the next question is sort of related. Where is the most blueprint overhead compared to C++? Because we know that blueprints are a little bit heavier. So
yeah,
where does that come from?
In our tests, we find that in our kind of like Fortnite use cases, it's about 11 to 12%, or 11 to 12 times slower to write something in Blueprint than it is native C++, which is a little bit actually faster than Unreal Script in UE3 was. But the most of that overhead is going back to the talking between the VM and the native code there again. So again, the most effective thing you can do for that is consolidate a bunch of functionality into one node, and then you're not paying the cost of that overhead going back and forth between the native layer and the VM. So none of the functions internally to it really cost much more than the C++. It's that transit time between native and the VM.
Okay.
And we're actually working on ways to improve that. We've optimized the VM code to do less memory copying and stuff like that to speed that up. And one of the things we're actually looking at is potentially just exporting blueprints under the hood to be C++ natively, so that VM overhead goes away completely. So that's a little bit longer term research project, but it's one of the things that we're looking at doing.
That sounds awesome.
All right, cool. Let's see here. Oh, okay. This is actually something I've been pretty curious about too. What's better, doing 8 line traces or doing 1 sphere trace? And it's not really the 8 that's important, but multiple line traces or 1 sphere trace. At what point does one outweigh the other?
So this is a little more physics-based, but I'm going to take a stab at it anyway. Because you're paying the overhead, doing the 8 line traces is probably a little bit slower because every time you do a line trace, you're going from Blueprint to native code, whereas when you do the sphere trace, you're doing one.
Call.
The other thing to consider is that each one of those line traces in the physics system has to go and query, a length of the line, basically. Sphere checks are super fast because it's just basically a point in a radius, so it's really easy for the physics engine to figure out what's within the radius. Whereas a line check has to go through and basically trace through the octree, which is a structure underneath that tells basically where everything is in relation to each other. So it's probably a little bit faster to do the sphere trace, if for no other reason than the VM overhead is less than the 8 line calls.
All right, then that's really good to know.
That confirmed
that really,
that
really does help a lot. And in the same strain, just calling 1 line trace node, what is the overhead from Blueprint compared to C++? And I guess they're looking for a hard number of some sort, so I'm going to throw 2 out there, and that'll be my guess.
Again, it's the VM overhead. So if you had like a super tight for loop or something like that, calling the line trace every time, you're going to get that worst case kind of 12 times slower. But it's just 1 line trace in the middle of a longer function that doesn't have a lot of kind of going up and down between the VM. You're not going to notice it nearly as much.
All right. Cool. Is the for each loop with break more expensive than just a regular for each loop? I ask because the regular loop is a node written in C++, while the loop with break is a Blueprint macro.
Slightly, but really not a huge appreciable difference on there. It's the for loop with break basically has a little more state to keep track of, but that difference is so minuscule you'll never really notice it in practice.
Okay, cool. That's neat.
That's a good question. The next one.
Yeah, this is a really pretty good one for a lot of stuff here next. The question boils down to, are blueprints platform agnostic? If I have blueprints running and I package out to Android, iOS, Windows, Mac, etc., do they perform better or worse on certain OSs, certain systems?
They because we deal with the VM, it's pretty much the same across platforms. The biggest difference you see is when we're more CPU constrained. So on mobile platforms, the CPU isn't quite as good at jumping around in memory when we're doing execution, which the VM kind of does a lot. So you'll see probably a little bit worse performance on a mobile constrained platform. But on a PC or the modern consoles where you have good out-of-order execution units on the CPUs, they'll be a little bit more performant there.
Okay, that's interesting. All right. So this one's a little bit long here, but after optimizing blueprints to the best of our ability, what would be the best or recommended way of going about figuring out minimum and recommended system requirements for a PC game? So, I mean, that's a pretty good question. I'm not sure if that's something we'll be able to answer, but I think we should take a whack at it. Build 50 PCs with varying degrees of strength and binary search to figure out which one has the 60 FPS. I don't know.
Yeah, you should have them go down to the QA lab, the hardware test lab, and see the ridiculous amount of Android phones, iOS phones, PCs, and stuff that's just laying out there. That's really the only way, is to kind of find the representative specs and then test to see how well you can do on each one.
Yeah,
I will point out it's much easier to kind of maintain a high performance and kind of do continuous profiling as you build up your game than try to squeak out a lot of performance at the very end. If you kind of think about it at the beginning, it's much easier to make kind of informed decisions on how you set things up and how you lay them out and make design trade-offs as you're going along rather than at the very end. Like when we do VR demos where you have to hit 90 frames a second and have ridiculous performance requirements, we start at 90 to 100 frames a second and maintain that rather than trying to go from 60 to 90 at the very end, because it's a much harder task. Once you've kind of built up a bunch of content, you have to make a lot more tough decisions. Which baby do you sacrifice?
Yeah.
You and those children today, I swear. Okay, so we have a question in about circular dependencies, and
favorite.
How should I deal with UMG widgets affecting the player controller, where the player controller spawns the widget without circular dependencies or using interfaces for everything? Is there a cleaner way to do this? Should interfaces always be used to avoid circular dependencies, even though sometimes they are okay? Wait, a little oddly phrased.
Yeah, so that kind of hits on an odd misconception. A lot of people, because originally circular dependencies just completely broke everything, right? So we said no circular dependencies kind of around the time when 4.0 was being released. And the way a lot of people went around that was to make an interface, because that you can reference the interface, but then you don't have blueprint A referencing blueprint B, which references back to blueprint A. A references the interface and B references the interface, but they don't reference each other, basically. So a lot of people think that interface's only purpose in life is to break those cyclic dependencies, and that's not the case. They were just the easiest way to do that. So cyclic dependencies, actually, thanks to Mr. Michael Beach, who's sitting right over there, fixed the issues with cyclic dependencies for 4.7. Then we found a few in the community, because you guys have a lot more people testing stuff than we do, and fixed the rest of those up for 4.8. So cyclic dependencies now shouldn't really be a concern. If they do break, please send us the repro and we'll get it QA'd and taken care of. But using interfaces and hacks like that to avoid cyclic dependencies shouldn't be something that's on people's radars anymore.
All right, that's really
cool.
cool.
I forgot the rest of the question, but I just wanted to say that.
Yeah, well, circular dependencies are always a thing that comes up, and I know you really shouldn't be that afraid of them at this point. We used to all be, like, avoid them at all costs. I remember those days back in the days.
So dark.
Someone asked in here, and I didn't actually post it up in the list here, but I'm curious myself. He's got 10,000 things he needs to update at once. What's the best way to do it?
That's a lot of things to update.
Yeah, I know.
So there's kind of two tactics you can do. If they really need to be updated all at the same time, the best way is to have some blueprint that's a manager or something that goes and broadcasts to all of them, rather than having all of them tick or do something like that. So basically one thing does the math of the calculations, then tells everything else what the result is. So if you have to do that all in one frame, that's the best way to do it. The better way to do it is if you can have it happen over, the course of 1, 2, 3, 4 frames maybe, you can do what's called amortization. And what that does is it breaks up the work into chunks. So maybe like update the first 1,000 the first frame, the second 1,000 the second frame, the third 1,000 the third frame, the 4,000 the fourth frame. So how you do that basically is you just, go through the first, n number, 1,000 elements, have them update on this frame. You can use a timer to update, on the next, 0.05 seconds or something to update the next batch. And then you spread that work out across a few frames so that you don't have this gigantic hitch every frame when you update that. So when we do like huge crowd simulations and stuff like that, we, update basically, a certain chunk of the crowd at the same time, but then spread that out over a couple different frames. And that's really how you are able to update a ton of those things in a way that, you wouldn't even notice the spread between 5 frames usually unless you're doing something really crazy.
Yeah.
We try to get away with tricks like that. And timer nodes are good for that.
Awesome.
Awesome. Well, it looks like that's about all the time we have. I know a bunch of people have meetings. I got meetings. Welcome to Epic, Meeting Central. So I'd like to say thank you to my guests, Wes and Nick, today. You guys have been amazing.
Thank you so much, Nick. Appreciate
Thank
it.
you.
Yeah. Yeah, thanks for calling in.
Yeah.
On such short notice, too.
I'm glad we finally got the networking issues sorted out.
Yeah, right?
We won't discuss all the background issues we had to go through just to get this man in. So.
Optimization, that's all it is.
They should appreciate all the work you did to make this happen.
Shelly over here,
Yep.
she's the true boss. She was the one doing the hard work. All right, so yeah, we will see everybody Thursday. See you guys in 2 days. The May 21st stream will be on recruiting and hiring. They're going to have Chance, Emily Gabriel, and Wythe Johnson on there to talk to you guys about recruiting, hiring, and all the fancy stuff that comes with that. It's totally out of my realm, of course. So yeah, enjoy. We'll see you guys around.
Thank you, guys.